Greetings everyone. I am Uday Sharma from the Triply Department of Institute of Aeronautical Engineering. Today I am going to discuss about direct and indirect sensing two-axis solar tracking system. Firstly, let us discuss why a solar tracking device is required. Suppose, let's see, there is a sun here and a solar panel placed right at an angle. And at regular condition, the solar radiation can be absorbed to the PV cells and electricity is made. But in the conditions of clouds or any weather changes, there is only partial formation or any partial solar radiation. And this PV cell cannot acquire all of the radiation. So by using a two-axial motor, the solar cell can be moved. It is moved in two directions, horizontal, vertical. And the solar panel can move to such a place that it can acquire most of the radiation produced and can produce the electricity. The two-axial motor moves horizontally and vertically using DC motors and few other components. Let us discuss about this. Solar energy is the most inexhaustible renewable source of energy known to humanity, as it can be acquired for a long period of time as the sun never dies. In order to increase the efficiency of solar energy systems, solar tracker is added to the expense of systems complexity and cost. As I have said earlier, to increase the efficiency in bad weather conditions, the solar tracker is used in or placed in the solar tracking solar energy systems. The two basic categories of trackers are single axis and dual axis. Single axis trackers only allows the solar tracker to move in horizontal or in vertical. But in the dual axis, it can both move in horizontal and vertical. So it is able to track the position of the sun precisely or perfectly. Let us discuss what are the components of this solar tracking device. The solar tracker mechanism is composed of Arduino Uno controller, DC motors, gearbox, LDR sensor, which is light dependent resistor sensor, angle sensor, timing circuit, Bluetooth module, and a motor driving circuit. The Arduino Uno sends command to the DC motor to specify the elevation and angles, azimuthal angles of solar panel, in which to maintain the panel always normal to sunlight, that is always perpendicular or 90 degrees to the sunlight. Two angle sensors are used to measure the physical angles or both outlet shafts of azimuth and elevation to make sure the desired angles are reached. Two angle sensors are used. Set of 4 LDR, light dependent resistor light sensors are used to trim the errors of altitude and azimuthal angles. The parameters of tracking system and monitored remotely on the supervisor and controlled computer program through Bluetooth module. As we can see in this diagram, the azimuthal angle is calculated respected to the angle of sun based on the directions. To track the position of the sun quickly, the Arduino Uno controller should firstly calculate the theoretical value of altitude, that is height, and angle, azimuthal angle. The theoretical value of altitude and azimuth angles are translated into digital commands for driving the DC motors to the corresponding positions. That is, with respect to the angle, the DC motor shifts the panel to any position required. Then the system automatically trims the altitude and azimuth angle of the PV panel according to the feedback signal of the processed LDR sensor module. The sunlight sensor module consists of 4 LDR sensors. As we have discussed, it has 4 light-dependent resistor sensors. 2 angle sensors are placed on outlet shafts of the altitude and azimuth angles for measuring the final value of altitude and azimuth angles and transmitting these values to the supervisory computer user interface. As we have discussed earlier, every components are connected externally to a computer module to analyze and comprehend the circuit. Let us discuss how this solar tracking is work. Firstly, the solar panel is placed. Then the LDR and angle sensor system measures the light, angle, altitude, and sends to the Arduino Uno and control platform. And this Arduino Uno processes the data and sends the output signal to the motors, which again converted to the gearbox and DC motors. They shift the location of the solar panel into the required position. A real-time clock is attached to this Arduino Uno, and the computer system is connected to a Bluetooth module, which is connected to the Arduino Uno, which drives the whole circuit or system. Track the sun in its vital to locate the position of the sun accurately. In this work sensing of the sun, position carried out in 2 stages, primary and secondary. Primary stage or indirect sensing performed via Sun-Earth relationship as a course adjustment, and secondary stage or direct sensing performed via set of LDR sensors as output tuning to trims the azimuth and altitude angles. In the primary stage, sun, that it is measured by timing of the Earth to Sun, where the sun falls, where is the sun at its peak or vital stage, where the sunlight falls. The secondary stage, the angle and the azimuthal angle and the altitude angles are measured, then calculated and sent to the Arduino Uno. If the weather is cloudy or dusty, the tracking system uses primary stage or Sun-Earth geometrical relationships only to identify the location of the sun. So the solar system tracks the position of the sun regardless the weather condition. LDR is a resistor whose resistance decreases with increases in light intensity. These 4 LDRs are placed on a circular plate separated by 90 degrees. Space rotation through perpendicular rectangular plastic sheets. Each LDR is placed in series with resistor of 1 kilo ohm. One kilo ohm and Wheatstone bridge circuit is formed using all the 4 LDRs and 4 resistors. If one of the LDR gets more light intensity than the others, node voltage difference will be received as analog signal, and the analog to digital converter channel of the Arduino Uno analyzes the data and generates logic signal to accue the motor to the tracker of the position which equal light is being eliminated to the pair of LDR. Let us take that four resistors, and one of them is getting high intensity. Then the Arduino Uno adjusts this and sets that each resistor or each LDR gets equal light intensity. If all the four LDRs are equally illuminated by the sun, then the analog voltage signals received at the ADC channel of the microcontroller will have equal values, and the microcontroller will not generate any logical signal to activate the motor. As we have discussed earlier, if all the resistors have the same intensity, the Arduino Uno does not provide any signal. If one gets more, the Arduino Uno sends signal to the motor so that it moves, and each sensor gets the same amount of light intensity. The LDR sensor module is attached to the panel with solar collected. A plastic box covered with tin foil is used for covering the electronic circuit. Two DC motors with gearbox arrangement are used to obtain the required movements. As we can see, the mechanical structure of the tracking system. Here, this is the tin foil cover box which covers the electrical components. As you can see, it can move in the bidirectional according to the angle or horizontal. Thank you. This is Uday Sharma signing off.